Welcome back to another lesson of sequences and series. This is part 5. In this video, we discuss the sum of the geometric series. A geometric series is the sum of geometric sequence. 3, 6, 12, 24, etc. is a geometric sequence. And the sum 3 plus 6 plus 12 plus 24, etc. is a geometric series. That is the difference between sequence and series. Okay, the formulae used to calculate the sum, we have it on the formula sheet. Sn equal to a r to the power n minus 1 divided by r minus 1. We use this formula if the common ratio is greater than 1. Okay, we can use this formula. Or if the common ratio is less than 1, we use another formula, Sn equal to a times 1 minus r to the power n divided by 1 minus r. Prove that in a geometric series with first term a and constant ratio r, the sum of the first n terms is given by Sn equal to a times 1 minus r to the power n over 1 minus r. Very important question. In most of the question papers we have seen this. Okay, let us start. We write Sn as the sum of the n terms. That is a plus ar square plus ar cube plus etc. up to ar to the power n minus 1. Okay, then that is our equation number 1. We multiply this equation by r, both sides, left side and right side. So we get r times Sn equal to, multiply each and every term by r, we get ar plus ar square plus ar cube. Look at the last term, ar to the power n. That is our equation number 2. Equation number 1 minus equation number 2 gives us Sn minus rsn is equal to, if you subtract the terms one by one, ar minus ar gone, ar square minus ar square gone, ar to the power n minus 1 also will be gone by. Now what is left? We are left with a minus ar to the power n. Okay, that is our third step. Now think about the common factor. Sn is common on the left hand side. Then inside the bracket we write 1 minus r, which is equal to, right hand side, what is common? A is common. Okay, that is very important step. So we get Sn equal to a times 1 minus r to the power n divided by 1 minus r. That is the proof. So practice 2 or 3 times, score the mark. X plus 3, 3x minus 1, etc. is a geometric sequence. Question A. Calculate the value or values of x. We are now familiar with this type of questions in arithmetic sequence. And now look at the question. It's a geometric sequence here. So we know that for geometric sequence, T2 divided by T1 must be equal to T3 over T2. We apply that idea here. X plus 3 over x equal to 3x minus 1 over x plus 3. cross multiplying, we get 3x minus 1 times x equal to x plus 3 times x plus 3, removing the bracket and simplifying very carefully into the standard form. 2x square minus 7x minus 9 equal to 0. Then we use factorization, or you can use the formula if you want. So we factorize and get 2x minus 9 times x plus 1 equal to 0, gives us x equal to 9 over 2, or x equal to minus 1. Question B. Calculate the sum of the first 20 terms of the sequence if x equal to minus 1. Remember that we are not using the other value. Here we are using x equal to minus 1. So the sequence, what is the sequence? Minus 1, 2, and minus 4, etc. We substitute x equal to minus 1. And the formula, okay, how do we apply? We use the formula here because here is the common ratio is 2 divided by minus 1, which is minus 2, less than 1. Minus 2 is less than 1. So we prefer the second option, that is Sn equal to a times 1 minus r to the power n divided by 1 minus r. Substitute into the formula and just use the calculator. We get the number 349,525. Simple question. So our topic is to find the sum. This video is mainly for the sum of the geometric series. Now let us look at few good questions from geometric series. Given the following number pattern, which is a combination of a linear and a geometric pattern, 3 half, 3 4 over 10, 3 16 over 50, etc. There is a linear sequence, that is 3 3 3, and there is a geometric sequence. Now, what is our question? Write down the values of the next two terms of this pattern. Obviously, the next term, immediately we can write 3 and look at the fraction term. You can see the sequence, geometric sequence, 1 over 2, 4 over 10. So the numerator is multiples of 4. 1, 4, 16. So 16 times 4 will give us 64. Look at the denominator, 2, 10, 50, multiples of, we multiply by 5. So 50 times 5 gives us 250. They are the two terms. Question B. Calculate the sum of the first 35 terms of this pattern. We already know that there is a linear sequence with number 3, and how many numbers can be possible there? Sequence begins with 3. So out of the 35 terms, 18 terms will be 3 like that. Sum of 18 terms is 3 times 18 gives us 54. The remaining 17 terms are from the geometric sequence. So we apply the formula, okay, the common ratio, calculate the common ratio, that is 4 over 5. Then Sn, we have the formula on the formula sheet. For S17 equal to, substitute very carefully, use the calculator, we get 2,44. Therefore S35, adding the two sums, we get 56,4. 4, 4. Okay, beautiful question. The sum of the first three terms of a geometric sequence is 31 and a half. The sum. Okay, we are doing the questions involving sums, and also we are doing selected questions here. The sum of the fourth, fifth, and sixth term of the same sequence is 3 and 15 over 16. Determine the value of the common ratio. A, right. Sum of the first three terms, that is A plus AR plus AR square, is 31 and a half. Now, sum of the fourth, fifth, and sixth, that is AR cube plus AR to the power 4 plus AR to the power 5 gives us 3 and 15 over 16. Common factor is R cube, R to the power 3. Inside the bracket, we can write A plus AR plus AR square. Okay, that is our equation number 2. Look at equation number 1. A plus AR plus AR square. That is inside the bracket here in equation number 2. What we do? Equation number 2 divided by equation number 1. Learn the method. You are going to get questions like this. Therefore, we get R cube is equal to 1 over 8. Use the calculator. Therefore, R is equal to cube root of 1 over 8 is 1 over 2. We got the answer. Calculate X correct to the nearest integer in the geometric series. Look at that question. X times 1 plus 1 comma 0 7 plus 1 comma 0 7 square geometric series is equal to 17 comma 888. Calculate X. So inside the bracket we have a geometric series. How many terms? We have 12 terms, and the common ratio, we calculate the common ratio, divide second term by first term or third term by second term, it is 1 comma 0 7. Then we calculate the sum using the formula. Okay, we substitute into the formula and we get S of 12 terms, sum of 12 terms. Use the calculator, substitution, and then use the calculator, we get 17 comma 888. Okay, so we use that value into the question. We get X times 17 comma 888 is equal to 17 comma 888. Therefore, X is equal to 1. Okay. Good question. Look at the beautiful question here. Given a geometric sequence 36 minus 18, 9, etc. Calculate the value of T1 plus T3 plus T5 plus T7 odd numbers up to T400 divided by T2 plus T4 plus T6 even numbers. Okay, so beautiful question. Let us start with the numerator and denominator. What is the numerator? T1 is A, T3 is AR square, T5 will be AR to the power 4. We write all of them. Up to T40, 499 is AR to the power 499 minus 1 is 498. Denominator, T2 is AR, T4 is AR cube. So we write all of them, and the last term T500 will be AR to the power 499. Look at the denominator. We can take r as a common factor. Our intention is to cancel the numerator and the denominator terms. Look at that. Inside the bracket, we get the same term as the numerator. So we cancel them and we get 1 over r. But already we know that r is minus 1 over 2. Using the terms here, 9 divided by minus 18 or minus 18 divided by 36 will give us minus half. Then we use the calculator and we get minus 2. Okay, so the value of this expression is minus half. So that is the end of part 5 of sequences and series. See you with more videos. Don't forget to subscribe and share these. Good luck.